Well, hi, good morning. Thanks so much for joining me here in my shop on October 5th. I have to stop and think about it a little bit. Today I'm going to be testing the 5 tubes that are in this radio. 1, 2, 3, 4, and 5. The problem with this radio at this point, one of the problems it's exhibiting anyway, is just low output. The low output could come from all kinds of factors, and it could even be a series of factors, each one kind of knocking down the output a little bit. But the most suspicious thing right off the bat, certainly in terms of tubes, is the output tube here. Output tubes work hard in these radios. In all radios, they're designed that way. Their business is to provide power to the speaker, and in the course of doing that, they themselves consume a fair bit of power. They get pretty hot, they work pretty hard, and they wear out. They wear out quicker and sooner than these other tubes, which aren't working nearly as hard. And again, it's a design thing. It's kind of done on purpose. If you wanted this tube, the output tube, to last as long as the rest, this thing would probably be 2 or 3 times as expensive to try to get it there. It'd be much larger and the like. So that's kind of how that goes. So that's the tube we're going to start with. We're going to start with this tube right here. This is a pretty common output tube. This one. This is an EL84. I can see it written right there. Made by who? Well, I can't read the name. It's got a Z on the end. Looks like Lorenz. Never heard of that. Okay, so I think an EL84 in Europe, this tube's called an EL84. In North America, it's called, I think, a 6BQ5 off the top of my head. I could be wrong about that. So if we take a look at my tube tester here. So this is a Weston tube tester. It's a Model 981. It's a well-known, well-respected tube tester. I have at least three high-quality tube testers, serviceman level tube testers, not scientific tube testers, but serviceman level tube testers. I've run the same tube multiple times, with multiple same tubes through the 3 testers to see how they compare, and they're all quite accurate. They all do the job fairly well. The only thing I would say about these is that even though they tend to quote, on some of them directly, they quote the transconductance, or the GM of the tube, which is what they're trying to measure. This is a dynamic tester, and the other 2 are also. I have some non-dynamic testers, but that's another story. Even though some of these testers will quote the GM right on the dial, this one will tell you that you read it off the scale. It won't actually write it here. This particular tester just has a rejection point value in there, and I guess that's GM. It's the low side of the range of, the good operating range of the tube. The thing is, what this tester will test a tube at and derive the GM may come up with a different number than another tester, because the transconductance has a lot to do with how you operate the tube. So if you operate it, I guess in one way, you might measure a higher GM. You test it and operate it in another way, you get a lower GM. If you open up the tube manuals, they will give you the GM for the tube, but they also give you the conditions under which that GM was measured. Transconductance, reverse resistance. The magic of the vacuum tube is hidden in that strange number of negative resistance. I'm not sure that's quite the right word for it. Okay, so let's get this guy on. Bring the first tube over. We're going to look up 6BQ5 on the chart here. 6B. Now you can't see the dial right now. I have another camera on it, so you'll see it in a moment. 6BQ5, and I think this one will even say, when we get there, 6BQ. You have to know your alphabet. That's a bit of a challenge for me sometimes. Here we come. 6BQ5 EL84 has it written right on here. So make sure the filament voltage is correct. 6.3. Okay. Signal level for the test is 4. The bias switch is 20H or 20 high. 20 high. And now these are the pin setting switches that control what is actually hooked up to what pin on the tube. And we'll set it according to these numbers. 05176, 05176. I'm letting you see this first tube, the whole process to getting it tested. For the other 4 tubes, I'm just going to show you the result as I do them. 0304, 0304, 30 for sensitivity. Its meter sensitivity is, I call this the cheater. And the guys who designed this tube tester at the last minute to get the needle to go where they wanted, they use this. Then they tell you that's the setting. F, I don't know that that's true. 1460. So 1460, if the meter is at 1460 or below, this tube tester company says throw that tube away, get a new one. If you want to know what the actual transconductance is, I don't know if you can see this, it has X5 written here. X5 means times 5 the reading. So if the reading came up to 1,000, the actual GM would be 5,000 in this tester, the way this tester tests tubes. And the other thing, it's got a little note here, PE. PE. Okay, PE. What does PE mean? So I'm looking for the manual. Quickly, Jim, find the manual. Oh, I can't find the manual. PE. Well, it might mean it's just telling you it's a pentode, but usually the notes here have an impact on the test. Okay, so we can plug it in. This has to be on F. This has to be 6.3. And you have to get everything correct before you plug the tube in. There we go. You probably saw the pilot light flicker there as I plugged in a cold tube. Draws a lot of power briefly. And this works a little bit like the dim bulb system I have on my bench. You can see the tube is lit right up. We're going to let it run for a minute or two while I look again for the manual, which, you know, no doubt I've put it in a really logical place and I no longer can remember. So, okay, well, we're going to gamble here. Tiny gamble. Okay, we're going to check for short. So one of the things you do with a tube tester is, I think all tube testers have some kind of short testing facility, and a lot of that is to protect the tube tester, because testing a tube with a short in it can be bad for the tube tester. Now, what I was saying, is there a lot of noise in this recording? A little bit. I have many microphones going in here this morning. Okay, so we'll do the short test. For the short test on this tube tester, it actually reflects right on the meter. I'm going to flip to the meter camera here, get a look at the meter. Okay, so on this lower scale, right where my finger is, you see like 200K, 100K, 50K, and the word leakage. This is where we're going to be doing the test on this scale. A good tube, the meter will pop up ever so slightly. It just seems to do that all the time as I run the test. And a little bit doesn't mean anything. Here we go. That's the little bit there. You can hear me snapping through the switches. That's number 1. So all the way back. Okay, we're in the tube testing position. So now there's all kinds of test switches here, 3 test switches. The one we want to test is the GM test. So I'm going to pull this down, the meter's going to go up, and I said before, the reject point on this tester is 1460 And you just read it directly off this upper scale here. 14. So 1460 is practically straight up. Okay, let's take a close look at this. Here we go. Is this the reason why the radio is quiet? I would say the answer is yes. This could be the reason, or could be a reason along with others for why this radio is quiet. You really want this to come up here, and if it gets to where my finger is, you're still supposed to throw it away. You're supposed to throw it away and replace it. Because now this tube tester unfortunately doesn't tell you what a good tube should do. It doesn't say, reject it here, but clap your hands if you're up around 2000. It doesn't do that. So where should it go? Well, we can figure that out. We have ways. Look in the book. 6BQ, just for interest's sake now. It's obvious this tube's got to be replaced. 6BQ. Isn't it 5? I guess it's 6. 6BQ5. Not in here. So it's a somewhat recent tube. Well, recent. Here. I'm right here looking for 6BQ5 in my RCA book. And it isn't in there. 6BQ6. So, as time went by, new tubes were being developed, and books and everything, tube testers were going out of date. This is an RCA, much newer book. 6BQ 6BQ5 power pentode. There's the PE part right there. Now what we're interested in is what is the GM. So we come down to typical operation, and we'll look over here. That's the way I do it anyway. I look for the see what it says micromoles. It's just a cheater way. 11,300 transconductance. 11,300. So where would that be on this scale? 11,000. 11,000. So this was a times 5, was it not? 6BQ5 times 5. So take 11,000 divided by 5, it's 2,000. So you would expect a good tube to come up just above the 2,000 mark. But where are we coming? We're coming way down there. Okay, well, that's a thumbs up because we found something that may explain the radio's operation. So I'm going to hunt down a good 6BQ5, and we're going to put it in the radio and we're going to play it. See what happens. Okay, let's see what we can find in here. So these are the tubes that I have previously tested just to make sure they operate, if not a quality test. 6BQ. I bet you it's these. Yeah. 6BQ5. I have quite a few of them. You see there's number tags on them. So that tells me I previously tested these carefully and I've kept track of the results. So I'm going to take a look at that, and we're going to pick one of those tubes, one that we believe is good right from the start, and we'll test it. Okay, testing a possible replacement tube here. Should be warmed up by now. And just flip cameras here so we can watch the exciting meter action. Is there a short? And no shorts. And what is the transconductance? Ooh-wee dog. Look at that. That's a beauty. That's as far as we need to go right there. Fantastic. If we look at this tube, see the glow is purple in the camera. It's just fading out in there right now. Phillips. So what I'm looking for is any sign of darkening on the inside of the tube. See, it looks like there's a little bit just below my thumb there. Very hard to see in the camera. There you can see kind of just down right under here. You can see a little bit of black thing. It's a very small amount. I look for those things because it suggests to me what kind of mileage is on a tube like this. These tubes, when they get to be high mileage, they have a lot of black that is built up. Exactly what that is, I don't know. Probably some ions of some sort that are finding their way to the glass. I don't really know what they are. Okay, so we're going to go back to the radio now. I'm going to pop this tube in, and we're going to find out if the radio's louder. So I'm going to get set up for that. Okay, I put the tube in. Here's the original, which I'll set over here. Now, how loud was this beforehand? Not loud at all. The set's not on yet. I had to turn this, in fact it's up full right now. Turn it up full just to perceive a bit of FM hiss. And on AM I had to have it up fairly loud to hear it. So we'll find out now based on the volume control and our ears. Here we go. Okay, just doing the dim bulb thing here for a moment. All looks well. Give it the works. I haven't got any of these buttons pushed down. I need something pushed down. How about that one? Turn it up. Oh. Ooh. What's happening? Well, this is on AM. Some dirt in the control. Well, we have a lot more volume. Is it all the volume it should have? I don't know. But I don't think so. It seems to be a little more muffled. Maybe I bumped the... Oh, yeah, that strange tuning thing again. It's a bass control. Oh, there we are. Okay, so how are we for volume now? Still seems a little low to me. You can hear the radio station this time. Oh, here's that weird tuning thing. That's the same station I've... Okay, radio sounds normal. Still a little quiet. FM, and I have an FM. I have this FM antenna on there. Something weird with this volume control. So a lot more hiss. Still need to turn it way up though. Let's see what we can tune in. The same tuning effect. Ooh, what was that? What was that? That sounded like something. Ooh, I don't like that one bit. It's not the tuning. What was that? Is that the tubes loose? I did not like that sound. You watch to see if the lights flicker. If the lights flicker during a sound like that. What is that? Just wait before something blows up. Okay, don't know what was happening there. Didn't like it one bit. Could be something very minor. Could be this tube is failing already. You know, it's been laying in a box or hasn't been utilized for 40 years. Maybe it's crapping out already. I'd pull it out of there, but it's so hot now I'd be on my way to the hospital with 3rd-degree burns. So we're gonna let it cool off. Let's stick it back in the tube tester. What was that sound? It just sounded like something serious. Yeah, okay. I'm going to go relax a little bit here and think about all this. Well, I think a better approach here, rather than try to test the tube that I think, maybe it's the cause of what was happening with that radio. I have another tube I'm testing here, another 6BQ5. Okay, passes the short test. Whoops, that's not what I wanted to come up. How about this? Now, once again, we saw that other tube go all the way up to 2000, and 1500 is where you get rid of it, and the first tube was way down here. What's this one do? Well, it's right on the time to get rid of it. Is this one, is this a good tube to try in the radio for now? Well, I think I have some better tubes here, frankly. Not too hot yet. I don't want to start going through all my tubes, testing them left and right. We have a chart already. Let me just take a quick peek here. We would try number 10. If I can find tube number 10 in this bag. Hey, what's with my camera not showing anything? It's like a still image. What's happened? What's happened? Okay, I'm going to try to reset the camera you're looking through. There we are. There's the tube. Huh, wonder what happened there. Stuff happens all the time, doesn't it? You got to roll with the punches. So number 10. Keeping vacuum tubes in a plastic bag, not really a good idea because the tubes are rubbing up against each other. The pins get a little bent out of shape. Some of the writing on the tube gets knocked off. So not the best way, but that's how I do it. So we're looking for number 10 here. Here it is, number 10. Okay, let's give number 10 a go and we'll see what happens here. Now, like I said before, this tube's been tested. Well, actually, this one, because it's an important tube, an output tube, I actually kept track of the results. So I think this should test good. Whew. So the tube glass got hotter after I pulled it out because there was so much heat inside the tube. When I first pulled it out, that heat was still deep inside the tube, but then it spread out to the glass. You can get hurt with these guys. Okay, short test. No shorts, jam. Voila! Okay, so that's a goodie. Excellent. You can see the pointer there. Also, okay, now quickly, before the glass gets hot, I'm running over and I'm going to stick it in the radio here. Get this one out. Yeah, it's cold. Now, do I really think it's a tube that caused that problem? No, I don't. I don't really think it is, but when things happen, you can think back, what was the last thing I did? Probably the last thing I did is part of the problem. So, turn it on again, play around, we'll see if those, that popping occurs. Okay, there we go. Everybody's quiet. Ooh. Seems like a lot more volume. So we're on medium wave. There's a lot more volume. Well, maybe that other tube is defective. Okay, not to jump to conclusions. But really, that's really made a huge volume difference here. So So right on where this station is located, I believe we're listening to, I'm not sure. We're listening to I'm not sure. Has the weird tuning thing disappeared? No. Station comes in here. And there. Okay, that's good. No doubt about it. No popping. Here we go. FM. Very quiet. Humming. There's a hum in there too. It's at the same station twice. This weird tuning thing is happening here too. Well, that makes it really strange, because you'd think this would happen, if it's going to happen, whatever it is that's going on, would only affect one band. You get the same weird tuning effect. You know, am I just not seeing there's a huge play in the capacitor? There isn't any. There's no play. Well, but on the volume side of things, so we're still low on the FM side. And that's probably due to the FM tuner tube sitting here. So that's the next one we're going to test. I think we've got a good, hopefully we have a good output tube now. And there was no popping. Well, I don't know. Looks okay. I'll have to make a note on this one. Very good. Let's shut this off. Let things cool off a little bit, and we'll go after that FM tube. The way now, you know what? I think I remember seeing the FM tube as an oddball. FM tube is an EC92. Usually this is I think an ECC 85. Usually EC92. Okay, I'm going to look into an EC92 and see if there's an alternative and all that kind of stuff before we, while I let things cool off here. Okay, well, as luck would have it, I'm going to do the cheapest video thing you can do here. I'm going to show you the screen here. EC92 is the same as a 6AB4, and I have lots. Well, I have a few 6AB4s in unknown conditions. So if it turns out this tube is weak, then I have replacements for it. Good. I'm going to pull the tube out here. And the tube has a shield on it, and the shield had a metal clip. It kind of almost looks like somebody has sanded this part away here, so the clip would make contact. This material that's gone black and silvery down here, this could be silver. This could be a silver, not the whole thing, of course. It's springy, so it's steel. Silver plated steel? Could it be that? Could it be that? Now here's the tube. Make sure it's the right. Again, it's a Lorenz EC92. Same as a 6AB4. Let's see if it's on the list here. 6AB4. Again, this tube may be too new. 6AB4. There it is. 6AB4. Okay. So we'll come along here and we'll set this up. So 6.3, signal level 1, 20L, so it's lower bias, 20, 2, 7, 3, 4, 5, 2, 7, 3, 4, 5, 4610. 4610. Oh. 46? Or that's a 5. Okay, double check here. 6AB4 30760. And I did, I read the line above. Oh, that's how mistakes are made. Oh, I read the line above all over the place. Totally wrong. 4. 21L. Well, that's hardly any difference. 30760. 30760. 5100. Now, what would have happened had I gone and plugged the tube in there? I don't know for sure. 38 on the sensitivity. F for the plate. 1190. Oops. Okay, we're all set here. Just a moment to warm up. And we are going to find out, is this also why the radio is weak? So I think the story with this radio, and I may have this mixed up, is it was in a school and it was on its way to the garbage, and the person who currently owns it grabbed it and saved it from the garbage. So what condition was it in? Probably pretty worn out, I would guess. Okay, we're ready now. No shorts. Safe to test. This tube, 6AB4 1190. So up around where my finger is there. Let's switch to the better view here. 1190. See, that's 1,000, so 1190 is just here. Here we go. Here we go. Ugh. It's a weak one. The 1190 again is the reject point. So if it doesn't get to 1200, this tube tester company says you got a chance to sell another tube. Okay, so we're pretty sure this guy's a dud. So I'm gonna have to get my my alternatives and use them. Use one of them. Okay, another tube. This one's a 6AB4 EC92, written right on it. West Germany. Lots of information coded on these tubes. These little numbers that are here look like they're smudged, but these things can all be analyzed. You can find out what factory these were made in, all kinds of stuff. Okay, we're ready to go. Stick it in there. Bent pin. It's a little tough. I have a pin straightener. I'm going to use my pliers here. I can crack the glass doing that, but I didn't. And that's probably an example of what happened to the tube while it was in its bag, its plastic bag. I'm very gentle with them, but... Okay, are you going to solve the weak FM in the radio? I'm asking that question too soon. Are you going to survive this test? No short. Checking again. 6AB4 1200 basically. 1200, better than that. Oh, it's even worse. It's worse than the other one. Okay, we got everything set right here. We've done something wrong. 6AB4, signal level 4, 21L, 30760, 30760, 5100, 5100, 38. That's where that's set. F. Well, to dig out another tube because this guy's he's not up to snuff. Okay. I'll hunt down another one. Well, anyone who's collecting tubes in an ad hoc way, like me, ends up with tubes in boxes, tubes, loose tubes, all kinds of stuff. So you need multiple storage systems. 6 AB4. No, I think there's 4 or 5 of them in here. Hey, there's one. There's one. Okay, well, let's try this one. First, is it really a 6AB4? You know, when you buy tubes from people and they're in boxes like this and they're pinned up, two things come to mind. The tube in the box is not the what the label says. Come on, I don't want to ruin the box here. Or the tube has actually been removed. It's a removal. Yes, it's just locked in there. Come on. Get another tube. Come on out of there. There we go. Six AB4. Now, this could be brand new, could be worn out, could be. So I don't test all my tubes ahead of time. I test them to make sure, basically the heater's there. That's pretty much what it amounts to. And it conducts. I do a emissions test. If it fails the emissions test, then it doesn't go in my collection. I have about a 30% failure rate on just getting tubes from people out of the blue. I don't do this very much. Here we go. 6AB4. I'm not out shopping for tubes. But occasionally, you know, the opportunity presents itself. You never know what you're buying. I just happen to have this box, which I'm going to be testing pretty soon. There's some really old ones here. These are great. These are real old guys. A little more rare, that's for sure, and not in too much demand. Here we go. Are you shorted? No. Are you any good? Yes. Yes. It's above the 12. Okay, fantastic. We got one we can stick in the radio, and we can find out, was the old tube dragging down the radio's performance? Put the shield on. I'll show you how this locks in. It's very important to shield this tube. Incidentally, in most FM radios of this age, they use a double triode in the receiver. In the FM tuner box, it's an RF amplifier and then the oscillator built into one tube. But this is just a single triode here. Just the RF amplifier. Okay, let's stick it in. This is the other one. I'm gonna keep it near the radio. No, put it with the other tube. Look, it's got a little. Really. Okay, let me just stick my head in here for a moment. Look and see. Okay, just looking for the pin gap. Totally flat sockets. Really tricky to get the tube in. There we go. Get a little rub. There we are. We're ready to go for another test. Speaker's still connected. Volume down. We're on FM. We are in business now. What I'm hoping for this time is a strong hiss and ability to tune stations. We should start on AM, reassure ourselves everything's working. Did I just shake this thing into quietness? Oh, maybe I was shaking the volume. It seems to have lost a lot of volume just from me shaking it there. Oh no. Okay, rubber mallet testing a little bit. Button. Doesn't seem to be. Let's double check. Doesn't seem to be the button. Some tube loose. Some of these I haven't even taken out of the socket yet. They're all a little wiggly. Huh. Still doing that weird tuning thing. I got to chase the stations around. Okay, well we won't worry about that other thing for a minute. It could have been the antenna connection here. Could have not. FM. Here we go. There's the hissiest area. You should be hearing a strong hiss about there, I would think. Let me wiggle this tube. Nope. Do the rubber mallet treatment. Nothing happening. Well, we can probably go with this tube for now on the assumption that this is probably functioning as a tube okay. Could be other elements wrong in here, B plus, all kinds of stuff could be wrong. I don't think all kinds of stuff is wrong. But that just doesn't seem to be enough. The antenna's crappy, you know. Maybe it's just the antenna. Let's just fool around here a bit. Well, that explains why it was louder in this area, because the antenna was tuned there. Let's go up here. Tune this thing. Well, we can ask ourselves this question now. Can you listen to this? Assuming my antenna is good, that's a bad assumption. If you can manage to tune in the station. Weird things going on. Have to watch out for a copyright hit. So we have more tubes to test yet. But in terms of the FM alone, this is the only tube that does stuff to FM. It doesn't affect the AM side. If we go back to the AM side, we have lots of volume. And if we go to long wave, lots of volume. Just a collection of noises. There are signals on the long wave band. Tricky to pick up. You need a decent antenna to do it. And I think you need to be in Europe. Because there's still broadcasts on long wave in Europe, I understand. Maybe the BBC's doing that. But we'll never get it over here. At least. Okay. I think I'm going to call it quits there. I've got other stuff I need to do today. I may not make another video or work on this radio for the next 4 or 5 days because it's a Thanksgiving weekend. Lots of family stuff happening here. So no videos for a while. And I think we're going to have to pick up here now. I should finish the tube testing just to be sure that they're good. The next thing in line for causing weakness, probably capacitors. The alignment thing is another possibility, but this guy may be very difficult to align. I'm looking down in the alignment holes here in the tuner. You push tools down these holes and twist up. You can see one of the things right there. They don't appear to be waxed up. Notice this can is soldered right on. Because any metallic variations in here will affect the radio's operation. Okay, so thanks a lot for watching, and we'll see what happens next.